Hi everyone, this is Rahul Chaturvedi and you are watching Telecom Notes. Please subscribe this channel if you have not subscribed yet so that you will get the notification for upcoming videos. And today's topic is the interfaces. We'll just study about the interfaces as well as the protocols used inside that particular one. So let's start. Coming to LTE interface, uh, we are having the user plane, control plane, having the applications in the user plane and NAS for the control plane. In the user plane, we are having IP, Internet Protocol, and for the control plane, we are having RRC. Then PDCP layer is for both of them, Packet Data Convergence Protocol, RLC, MAC, and physical layer. In LTE, air interface of EUTRAN based on OFDMA in downlink and SCFDMA in uplink, FDD and TDD duplex methods, scalable bandwidth from 1.4 up to 20 megahertz, data rates up to 100 Mbps in downlink and 50 Mbps in uplink. Before continuing for further interfaces, let's have a quick view over the LTE protocols working as mentioned in the previous slide of LTE interface. For detailed information, we are having the LTE protocol video also. Let's have a look over that particular video and stay back on this video for continuing. At the left hand side, it's giving you the overview of the protocols that in PDCP layer we are having header compression and ciphering, but we are having the integrity also for the control plane. And coming to the RLC, we are having segmentation and ARQ. In MAC layer, we are having MAC multiplexing, HARQ, and the prioritize. We are having one more thing, that is the prioritization method that has been just explained in the protocol video. Coming to the physical layer, it's having the coding, modulation, and antenna and resource mapping. And coming to the right hand side now, it's the vice versa because it's the receiving portion of. So in this you can have a look. It's demodulation, decoding, HARQ, ARQ, and MAC demultiplexing, hybrid ARQ, reassembly, deciphering, header decompression. So it's vice versa of the transmitting. It's the receiving part. Coming to the X2 interface, it's been the X2 interface is there for inter-eNodeB interface and it's having the control plane X2 AP, that's the application protocol, SCTP, IP, layer 2 and layer 1. While in case of the user plane, you will find user PDUs, GTP, UDP, IP, L2 and L1. GTP is the tunneling protocol for the user plane, UDP is the user datagram protocol. So coming to the details now, X2 interface, inter-eNodeB interface, intra LTE access, system mobility support for UE in LTE active, context transfer from source eNodeB to target eNodeB, control the user plane tunnels between source eNodeB and target eNodeB, handover. The control plane of the X2CP interface allows the signaling between eNodeB. The user plane X2UP interface allows the transfer of application data between the eNodeBs. So at the left hand side, it shows you the control plane and user plane between the two eNodeBs that is having the interface X2. Coming to S1 interface, in S1 interface we are having two different interfaces, S1 MME and S1U. S1U is for the user plane that has been just put it in between the eNode B and S gateway, and S1 MME lies between the eNode B and MME. So in the S1 interface connects the eNode B to the evolved packet core. This allows both signaling and the data to be transferred between EPC and EUTRAN. Coming to the S1 MME first, the control plane of the S1 interface allows signaling with the MME. MME and UE will exchange non-access stratum signaling via eNode B through this interface. Example, if a UE performs tau tracking area update, the tracking area update request message will be sent from UE to eNode B, and the eNode B will forward that particular message via S1 MME to the MME. S1 AP is application protocol. Now coming to S1U, the user plane of the S1 UP interface allows the application data transfer through the serving gateway. It is a pure user data interface. GTPU is the application protocol that tunnels the user data between the eNode B. With serving gateway, the user side bearer will have to use a signal from MME to this user. Coming to S6A interface, S6A interface lies between MME and HSS. Now coming to the details of this particular S6A interface, it enables transfer of subscription and authentication data for authentication, authorization, user access for the evolved system between MME and HSS. The HSS can, during this procedures, also store the user current MME address in its database. Now coming to S5 and S8 interfaces, S5 is used for the local and S8 is for the roaming purpose. So coming to the S5 interface first, S5 interface connects the serving gateway to the packet data network. Both control plane signaling and user plane data exists in this. The PDN gateway provides the connectivity to the set of IP services. So the S5 represents the main connection for application data across the evolved packet core. S5 is used if serving gateway and PDN gateway belongs to the same network, not roaming case. Coming to the S8 interface, the S8 interface is similar to the S5 interface, but it terminates at a PDN gateway belonging to a different PLMN. This interface is used by end users who are roaming away from their home PLMN. That means the visited PLMN. Coming to S10 and S11 interface, S10 interface lies between MME to MME, having the details, the interface between MME and other MME, reference point between MMEs for MME reallocation, example handover, and MME to MME information transfer, used during inter-MME tracking area updates. S10 is a pure signaling interface, so user data runs on it. Coming to S11 now, S11 is the interface which lies between MME and S gateway. S11 interface, this is the interface between MME and S gateway. This allows signaling information for mobility and BRN management to be transferred. Application data does not use the S11 interface. A single MME can handle multiple serving gateways, each one with its own S11 interface. Coming to RX and SGI interfaces, RX interface lies between PDN and PCRF. An RX interface between PCRF policy and charging rules functionality and the external PDN network operators IMS. Coming to SGI, SGI is just lies between PDN and P gateway. So SGI interface used by the PDN gateway to send and receive data to or from the external data network. It is either IPv4, IPv6 based. This interface corresponds to the SGI interface in 2G and 3G. Interworking between the PLMN supporting packet-based service and PDN. Other LTE interfaces, just like S3, it is the interface between SGSN and MME, enables user and bearer information exchange in inter 3GPP, access network mobility in idle and or active state, based on GN reference point as defined between SGSNs. S4, it provides the user plane with the related control and mobility support between SGSN and the S gateway, based on GN reference point as defined between SGSN and GGSN. Coming to S7, it provides transfer of quality of service, that QoS policy and charging rules for the PCRF policy charging rules functionality to policy and charging enforcement functionality in the PDN gateway, PCEF. Coming to S9 interface, it's the interface between HPCRF to VPCRF, that is home policy charging rules functionality, and visited PCRF is the visited one. It's used in the roaming cases. It is also used in VPLMN for the enforcement of dynamic control policies for the HPLMN. Coming to S12, direct tunnel from the serving gateway to RNC. S12 is the user plane interface using the tunneling user data directly between the S gateway and UTRAN. This would allow the forward packet data from 3G to the serving gateway of the PDN gateway. Coming to S2, provides the connection between the 3GPP2 or WiMAX with the LTE. Coming to SGS now, provides the connectivity between the MME and MSS. So that's all from my side, and thanks for watching the video. Stay connected guys, there is a lot more coming up next to you. Thank you.